And today in our mathematics session I am going to deal with some more concepts related to the surds. In the previous class we learnt about the definition of surd, addition, subtraction, multiplication and division of surds, right? And then different types of surds like simple surd, mixed surd, as well as surds based on the order, that means n value, and surds based on the number of terms. Now on the board I have few questions related to those simplifications, and I will solve these questions, and afterwards I will move for the next idea, which is going to be the change of the order. Right now just look this, I am going to solve these questions. See, these questions related to the simplifications, conversion of the form, as well as additions, multiplications and everything involved these questions. Now if you look, the first question is you need to simplify this one. What is this? 1 divided by cube root of 4 power minus 5. What is the simplified value for that? What is another form, simplified form for this? So you need to simplify it like this: 1 by cube root of 4 power minus 5. We know that this cube root can be written as power 1 by 3. So 1 divided by 4 to the power minus 5 to the power 1 by 3. Is there anything wrong? Nothing. 4 to the power of minus 5 is under cube root, so we will write it like power 1 by 3. Now 4 to the power minus 5 into 1 by 3 can be written as 1 divided by 4 to the power minus 5 by 3. So since it is 1 divided by 4 to the power minus 5 by 3, this 4 power minus 5 by 3 is in the denominator, and if you simplify, it will become like 4 to the power 5 by 3. So this is the simplified value for this. 1 by cube root of 4 power minus 5 can be written in this way. You need to observe the steps how we are changing. Cube root, I rewrite the cube root as power 1 by 3, and then I multiply these two. Since it is in the denominator, if you reciprocal, it becomes like 4 power 5 by 3. And further, if you need to simplify, again this is 4 power 5 by 3. So you may write it like this. For suppose 4 power 5 to the power 1 by 3. And if you wish to simplify, you will write it like cube root of 4 power 5. Right? Since it is cube root of 4 power 5, you may write it like, we know that under the cube root, if there are 3 4s, you will write 1 4 out. So I can write it like this: cube root of 4 power 3 into 4 square. So cube root of 4 cube can be written as 4 into cube root of 4 square is 16, and that may be your answer. See, the simplified value for this is maybe 4 power 5 by 3, maybe cube root of 4 power 5, and maybe 4 into cube root of 16. If you wish to convert it into the pure surd, that is cube root of 4 power 5. Or if they ask us to convert it into the mixed surd, it may be 4 into cube root of 16. It depends upon the options given in the problem, right? See, to solve this, cube root of 4 cube. Yesterday in the class we mentioned that nth root of a power n is equals to a. Is it right? See, since nth root of a power n is a, and cube root of 4 cube is 4, and the remaining value is 16. Right? Once again, just look here. 1 by cube root of 4 power minus 5 I have in my hands. To simplify this, just I am writing this cube root as power 1 by 3. Now just multiply these two. 4 power minus 5 by 3. 1 by 4 power minus 5 by 3. Since it is in the denominator, if you reciprocal it becomes like 4 power 5 by 3, right? So that is 4 power 5 by 3. Again, you just rewrite it like 4 power 5 to the power 1 by 3 by the laws of exponents. And if you write like that, this is cube root of 4 power 5. And then cube root of 4 cube into 4 square, and then cube root of 4 cube is 4, and your answer is 4 into cube root of 16. There ends your task, right? So this is the way to simplify this 1 by cube root of 4 power minus 5. So in the same pattern, I am going to simplify some more problems. Still, if you have any confusion, just follow all these things. At the end, automatically you will be strong at these simplifications again, right? See, just have a look. So the answer, the simplified answer for the 1 by cube root of 4 power 5 may be what I said, 4 power 5 by 3, or cube root of 4 power 5, or 4 into cube root of 16, right? I am going for the next problem. Just observe all these things. Still, if you have any doubts, just note them and I will solve those, right? Right. The next one is what it is given here. Cube root of 8 to the power minus 1 by 2. You need to simplify that. It may be somewhat simple when compared with the first one. Yeah. Just look here. This is cube root of 8 to the power minus 1 by 2. See, we know that 8 can be written as 2 cube. So this is cube root of 8 can be written as 2 cube, and the whole thing is to the power 1 by 2. Just I mentioned you the basic fundamental thing of the nth roots is that what it is. Nth root of a power n is a. With the support of that law, this cube root of 2 cube can be written as 2. I am right? So this is 2. 2 power minus 1 by 2. So 2 power minus 1 by 2. For some time you just keep that minus out, then it becomes like 2 power minus 1 by 2 can be written as 2 power 1 by 2 to the power minus 1. Right? Surely right. So since it is 2 power 1 by 2 minus 1, 2 power 1 by 2. This 2 power 1 by 2 is nothing but root 2. What you say? This is root 2 to the power minus 1. And since it is root 2 power minus 1, your answer may be 1 by root 2. Just observe once again, the given problem is cube root of 8 to the power minus 1 by 2. This cube root of 8 can be written as cube root of 2 cube. Right? And cube root of 2 cube, like with support of this law, it can be written as 2 power 1 by 2 to the power minus 1. This is root 2 power minus 1, and that is 1 by root 2. Your simplified value may be this one for this problem. Right? Simplification is according to the answers as well as the options. We need to simplify the given nth roots or the surds in this manner. Right? So this is the second thing. Whereas coming for the third thing, this is cube root of 250. If you observe that cube root of 250, it is in pure surd form. If you look, this cube root of 250 is in the form of a pure surd. So you need to convert this cube root of 250 into a mixed surd, or they ask you to find the simplified value for this cube root of 250. So for that simplification, you need to prime factorize this 250. Since it is a smaller number 250, we are very familiar with the prime factorization of 250. If you don't know, you just go with the prime factorization, and I am writing it like cube root of 250 can be written as 5 cube into 2. 125 2s is 250. What you say? Surely it's right now, right? So 250 is 125 2s, that 125 is 5 cube. Since I know it, I am writing like this. If you don't know this, then go for the prime factorization of 250. If you do the prime factorization, automatically you will get all these things like 2 and then 3 5s. So this is 5 cube into 2. Again, with the support of the law, this cube root of 5 cube into 2 can be written as cube root of 5 cube into cube root of 2. In the last class, we discussed about the multiplication of surds. If the order is same, then the multiplication is allowed. Since it is cube root 2, you just split it like this. Cube root of 5 cube into cube root of 2. Then cube root of 5 cube is 5, and that is cube root of 2. Then your answer for this problem is directly 5 into cube root of 2. So this cube root of 250 is in pure surd format, and this 5 into cube root of 2 is in mixed surd form, and we call it as simplified value also. So they may ask you to convert this value into mixed surd. So then that conversion is this one, 5 into cube root of 2. Right? Nothing is complicated here. Just you need to go with the usual simplification. Right? Then after this cube root of 250, I have one more problem here. 2 by 7 into cube root of 7. Here for this cube root of 250, I converted a surd in pure form to the mixed form. Now the next problem is given in mixed form, and now I am going to convert that mixed surd into a pure surd. What is given there? If you look, that is 2 by 7 into cube root of 7. This is a surd part and this is a rational number. So it's a mixed surd format. To convert it into pure surd, you need to send this 2 by 7 into the cube root. Since we are sending 2 by 7 into the cube root, just once again I am repeating. If you have under the cube root a number for 3 times, you have to write 1 time outside the cube root. But here we have 1 time outside. So if you are writing inside that cube root, you need to take 3 times. Then it becomes like this is equals to cube root of 2 by 7 into 2 by 7 into 2 by 7 into 7. This 7 as it is I am writing, but this 2 by 7, if it comes in, it becomes like 2 by 7, 2 by 7, 2 by 7. Now 1 7 get cancelled, and on simplification you have that cube root of 2 into 2 into 2 is 8 divided by 49. Right? That is the pure surd format, right? Now then no need to write this cube root of 8 as 2. If you write like that, again it becomes like a mixed surd form, right? Now what I did here is just I converted a given mixed surd into a pure surd. So these two are actually same. These two are same. The value of these two surds, these two numbers is same, right? But this is in mixed surd format. This is in pure surd format. We are able to convert every simple surd, every single term monomial surd into pure form as well as in mixed form, right? Now I am expressing this mixed surd into pure surd format. Now this is the thing, right? So totally I did 4 problems here now, 4 simple problems based on simplifications. Now I have some more things here. I will do one by one, right? 2 problems are related to the additions and subtractions, and more 2 problems are related to the multiplications as well as divisions. Just have a look, and I am moving for the next problem. Now if you look there, the next problem what I mentioned here, it is 2 root 18, see 2 root 18 plus 3 root 50 minus 5 root 72, it is given, and they ask us to find the simplified value for this one. How to simplify? To simplify this, what we need to do? What we need to do? See, to add or to subtract 2 different surds, we need to maintain those surds in similar form, right? Addition and subtraction of surds is possible only if the surds are in similar surds. If they are in similar surds, then only the addition and subtraction is possible. Now if you look, all the surds are in square root, second ordered surds. So since the order is same, so you just try to convert them as similar. To convert them as similar, you need to prime factorize everything. This is root 18. This 2 into root 18 can be written as 3 square into 2. What you say? 9 to 6, 18. Plus 3 into this root 50 can be written as 5 square into 2. Right? Right. And then minus 5 into root 72 can be written as 6 square into 2, 36 twos. Okay. So I am going to convert everything into similar form. Now if you look, this is equals to 2 into, under the square root, if there is any number twice, you need to write once outside the square root. I think you know it. Since it is cube root of 3 square, you just write 1 3 out and then you left with root 2. Plus 3 into, since there are 2 5s, write 1 5 out and then into root 2. Minus 5 into, write 1 6 out into root 2. Now this 2 into 3 into root 2 can be written as 6 root 2. 3 into 5 root 2 can be written as 15 root 2. 5 into 6 root 2 can be written as 30 root 2. Now totally, here I have root 2 6 times and there root 2 for 15 times and here root 2 for 30 times. You need to simplify. This 6 plus 15 is 21. 21 minus 30 is minus 9 and your answer at the end is minus 9 root 2. And this is the simplified answer for that given problem. For the addition of surds, this is your answer. Just have a look once again. The problem is given like this. We need to add and subtract these surds. We know that addition and subtraction is possible only for similar surds. So to make them as similar, you just prime factorize everything under that root. Maybe square root, maybe cube root, maybe fourth root and in generally nth root. Now if you prime factorize this 18, it becomes like 3 square into 2. And here it is 5 square into 2, there it is 6 square into 2. Under the square root, if any number is there for 2 times, you need to write 1 time outside. So write 3 out becomes 6, 5 out becomes 15, 6 out it becomes 30. Now at the end, 6 plus 15 is 21, minus 30 is minus 9 root 2, and this is your answer. So these are certain problems related to the additions, subtractions, multiplications and division of surds. Right? Still we have some more problems and we are going to discuss one by one. Right? I am going to clear this. Yes. Look about the second problem. See, I think it is clear for all of you. I will mention the problem here once again. You just try for 1 minute, maybe a fraction of second, and then I will go to solve. Right? Yeah. The next problem, what we are going to discuss here, it is. See, this is the problem here. Cube root of 24 plus fourth root of 81 minus cube root of 192 plus fifth root of 32. This is what we need to simplify. Just observe the problem. This is a cube root, this is a fourth root, this is a third root, and that is a fifth root. And we need to add and subtract depending upon the sign whatever it is given. So you just try for a fraction of second and I will give you the solution now itself. Just try for a fraction of second. Yeah, I think many of you tried it and I am going to discuss it and then you just check with your answer, right? See, this is cube root of 24. Now I am writing this 24 as 8 3s is 24. 8 is nothing but 2 cube into 3. Again, we learn the support of the prime factorization. On the prime factorization, this 24 can be written as 2 cube into 3. Now this is fourth root of 81, you just write it like fourth root of 3 power 4, right? And then minus cube root of 192. What is the prime factorization of that 192? If you don't know, you just go with the prime factorization, what I said. See, 192, just for 192 I am doing here, 192. Can I move with 3 or something? 3. If I move with 3, 6 is what? 18 and then 12. 64 into 3, right? So I will write it like 4 cube into 3. 64 3s is 192. Plus fifth root of this 32 can be written as 2 power 5. Now just have a look here. This is cube root of 2 cube into 3. Fourth root of 3 power 4 minus 3 into 4 cube into 3 plus fifth root of 2 power 5. We are going to get the simplified value for the addition and subtraction of these given sets. So, by the support of the basic fundamental law of the surds as well as nth roots, nth root of a power n is a. With the cube root of 2 cube can be written as 2, but 3 is inside only, so you just write it like cube root of 3. 2 into cube root 3. Now plus fourth root of 3 power 4. This is fourth root and under that root we have 4 times 3, so you just write it like 3 minus cube root of 4 cube. Under the cube root you have 3 4s, so you just write 1. 4 into cube root of 3 plus under this 5 you have 5 2's, you just write it like 2. Fifth root of 2 power 5 is 2. Now you need to simplify. This, if you observe, this is cube root 3 and this is also cube root 3. So these two are similar sets. And if you observe these two are normal numbers, they may be, we may call it as similar. Right? Since this is cube root 3, this is cube root 3, you just add these two. You just simplify, combine these two only. But you don't have any chance to combine this 2 into cube root 3 with this root 3. Just like this is an apple and this is a banana. You don't have you have no option to add an apple and banana, right? So this is 3 and that is 2 and that summation is 5. And now this is 2 into cube root 3 minus 4 into cube root 3. Cube root 3 is 2 times here and then 4 times there and we are going to subtract. So minus 2 into cube root 3. And then what is your answer? 5 minus 2 into cube root 3 is your simplified answer for the second problem. Right? Right. Just if you did it earlier, just check with this answer whether it is right or wrong, how you proceed. Just check once. Right? I am moving for further problems and these problems are related to the multiplication as well as division. Right? Yeah. Next problem. If you move for the next problem, what it is given? See, this is given like that. The next problem is about multiplication. Fourth root of 4 into fourth root of 12 is given. You need to simplify. See, already I mentioned you in the previous class that addition and subtraction is possible only if the surds are similar, whereas multiplication and division is possible only if the surds are of same order. Here both the surds are of same order, like fourth root and fourth root. Then here you have a chance to multiply those. If you multiply, it becomes like fourth root of 4 into 12. Under that fourth root you need to multiply these two numbers. Now I will write like this is fourth root of 4 into, I am writing this 12 as 4 into 3. Right? Right. This 4 into 4 can be written as 2 power 4. So 4th root of 244 into 3, if I am right. This is 4th root of 244 into 3. Then by the support of the fundamental law, that 4th root of 244 is 2 into 4th root of 3. And the final simplified answer for the given problem is 2 into 4th root of 3. After multiplication of these two, we have this value as your final answer, that 2 into cube root 4th root of 3, right? So this is the way how to multiply two surds if they are in same order. If they are not in same order, how to multiply? That's what we are going to discuss afterwards here, right? Yeah, I am going to erase the next one. See, just have a look there. See, 5th root of 7 into 5th root of 243, you need to simplify, right? This is 5th root of 7, right? So you have two chances here. One thing you just multiply, yeah. See, this 5th root of 243, this can be written as 5th root of 3 power 5, I think. 81 3. This is 5th root of 3 power 5. Since it is 5th root of 3 power 5, you just write it like 3. This is 3 and this is 5th root of 7. 5th root of 7. This is 3 and this is 5th root of 7, and you need to multiply these two. You just multiply in this manner, that 3 into 5th root of 7. Okay? Yes, in the previous class itself I mentioned the difference between that 5th root of 7 and 5 into root 7. Just now look here, this is 5th root of 7 into 5th root of 243. Both the surds are of the same order, 5th root. Then you have a chance to multiply these two numbers. After multiplication, again you just write the 243 as 3 power 5 and then you will simplify. But before that multiplication itself, I am writing this 243 as 3 power 5 and I have 3 as the simplified value for this one. And now I am multiplying this 3 with this 5th root of 7 and your answer is 3 into 5th root of 7. There ends your task. Right? Yeah. Now what I am going to tell you is, in between this, already I mentioned you that the difference between 5 into root 7 and 5th root of 7. Okay, 5 into root 7 is the product of 5 and root 7, whereas 5th root of 7 is 7 power 1 by 5. You just maintain that difference in your mind, right? And then I have one more problem to solve for you. Square root of 80 divided by square root of 5. Division of two surds. I mentioned you that division is also possible only if the surds are of the same order. Right? Both the surds are square roots, that means they are of the second order. Since they are of the second order, you just directly combine. So square root of 80 divided by 5 you will write. See, square root of 80 divided by 5 is square root of 60 and your answer is 4. And that is your answer. Right? So, we learned how to add, subtract, multiply different surds. Based on all these things, we have a chance to formulate different formulas here. Now I am just listing all those formulas here. You just take a screenshot or you go with the running notes. Right? Yeah. Just a minute. Yeah. See what are the different formulas still we have in our hands. That nth root of a power n is equals to a. Is it right? Nth root of a power n is equals to a. That's the one formula. And the other thing is nth root of a into nth root of b can be written as nth root of ab. We are able to multiply these two because they are of the same order. And nth root of a divided by nth root of b also can be written as nth root of a by b. Since we have a chance to divide, because they are of the same order. But if the orders are same, then we don't have a chance to add and subtract. So what I am going to mention here it is, if it is nth root of a plus nth root of b, it cannot be written as nth root of a plus b, right? Similar for subtraction also. This is not equal, but for multiplication, for division, if they are of the same order, directly we can. Right? And to add, the surds must be in similar form. So first that, if you some p times the nth root of a plus some q times the nth root of a minus some r times the nth root of a, like that if you have, All these surds are similar because they involve with nth root of a, but the coefficients are p, q and r. Now you just add those coefficients and your simplified value is p plus q minus r into nth root of a, right? So now these are some basic fundamental things related to the addition, subtraction and multiplication, division of surds, right? And afterwards I am going to discuss how to change the order of the surd. Just have a look about these things. You may call them as loss of nth roots or loss of surds, and afterwards I am going to discuss how to change the order of the surd. Just have a look. Yeah, I am going to erase these things. Now, what we are going to discuss. See, already we know about the order of the surd. For example, if you have that cube root of 2, what is the order of this surd? Cube, right? See, the order of the surd is 3. You mention it as 3. Now, what I am going to do is I am going to change the order if possible, right? Sometimes it is possible and sometimes it is not possible, right? Since this is cube root of 2, I will write it like 2 power 1 by 3, right? Since this is 2 power 1 by 3, you just multiply this 1 and 3 with some other number, or maybe with 2, or maybe with 3, or maybe with 4, like that. See what I have? Cube root of 2. Now this is 2 power 1 by 3. Now I am going to multiply these two numbers with some other number. You may say, for suppose if you multiply with 2, it becomes like 2 power 2 by 6. Or if you multiply these two numbers with 5, you may write it like 5 by 15. Or if you multiply this with some, maybe you say some 24 by 72. See, this cube root of 2 can be written as 2 power 1 by 3. And since it is 1 by 3, you just multiply this 1 by 3, both the numerator and denominator, with any number as you wish, depending upon the way how to proceed. Right? Just I gave an examples related to that. Here I am just multiplying with 3, and then if it is 5, and then if it is 24. Now how to simplify this? To simplify this, you have a chance that this can be written as 2 square power 1 by 6, right? And it can be written as 2 power 5 to the power 1 by 15, and this is 2 power 24 to the power 1 by 72. Now if you look, this 2 square power 1 by 6 can be written as 6th root of 2 square, which is 4. And this 2 power 5 power 1 by 15 can be written as 15th root of 2 power 5. This 2 power 5 is 32. And it can be written as 72nd root of 2 power 24. See, actual thing is cube root of 2. This cube root of 2 is same with this 6th root of 4. And this is same with this 15th root of 32. And this is same with this 72nd root of 2 power 24. The given cube root of 2 value and the given 72nd root of 2 power 24 value both are same. But if you look, this is a surd of order 3, whereas this is a surd of order 72. And this is a surd of order 3, this is a surd of order 15, and this is a surd of order 6. And if you observe, all these four values are same, and this is of order 3, this is of order 6, this is of order 15, and this is of order 72. So now we have a chance to convert the order of the surds from one order to the other order, if possible. What I am mentioning it is, if possible. Say here it is 1 by 3, right? I am multiplying these two with 3, these two with 4, these two with 24, or these two with 5, then I have a chance to convert. Right? If anybody asks you to convert this cube root of 2 into a surd of order 7, is there any possibility like that? If anybody asks you to convert this cube root of 2 into a surd of order 3, then into a surd of order 6, then you have a chance. What is the chance? You just make this denominator as 6. To make it as 6, you are multiplying with 2, then it becomes like 2 power 2 by 6. And if anybody asks you to convert this cube root of 2 into a surd of order, maybe you may say it as some 18, right? If anybody asks you to convert into third of order 18, then how you need to proceed? You need to make this denominator as 18. For that, you just multiply these two things with 6, then it is 2 power 6 by 18. If it is 2 power 6 by 18, then again you have a chance to write it like 18th root of 2 power 6, and that is equals to 18th root of 64. Right? See, so this is cube root of 2. So we are able to convert this cube root of 2 into different sets of orders which are multiples of this 3 itself. But if anybody asks you to convert this cube root of 2 into a third of order 7, then it is not possible, most probably. Right? So just have a look here, what I am discussing there. Here, right? Converting a third from one order to the other order. Here it is a third of order 3, and here the same third with the order 6, 15 and 72, 18, like that I am giving. Right? So with this change of order, this order changing thing concept is helpful to compare different thirds as well as in multiplication also. Just have a look the way how you converted the order, and then I am going to deal with different problems related to the order change, right? And afterwards I move for the next beautiful concept, and that is the rationalization. Now just have a look, and I will give you some situations, problems related to this order change concept, and then we need to move for the next one, right? See, in the last class we are discussing all these things with the different numbers, right? See, the fifth point is about the, most probably sixth point is about the addition and subtraction, seventh point is about the multiplication and division. You just take the last of thirds which I mentioned in the before this as eighth one, and then you just take this order changing concept as the ninth one, right? If you maintain those numbers, just look here, and if you need, have a screenshot. Right? For suppose with this concept of the order changing, if anybody asks you to multiply the thirds of different orders, see, one more thing what I am going to tell you is, see, just observe it. If I have that nth root of a, it can be written as a power 1 by n. Since it is a power 1 by n, we will write it like a power m by mn. Since it is a power m by mn, we are able to write it like mnth root of a power m. What you say?